Good evening, everybody. For those that don't know me, my name is Peter. Last time I was here, there weren't so many new faces. I think there's a lot of new faces now. I work at Binary Digital, and tonight I'm here to talk about this buzzword, serverless. How many of you have heard of this serverless architecture? So it's been a big buzzword in 2018, and hopefully tonight we will get to unpack and define what a serverless architecture is. So this is a bit of an impromptu kind of presentation, but hopefully, together we can kind of like figure out what a serverless architecture is. So, like I said before, 2018 seems to be like the year of a serverless architecture, and we hear a lot of talk about serverless over actually using your own in-house servers. So let's probably take a look at where serverless architecture started. Well, not necessarily started, but where the whole phenomenon came about, and why exactly people are leaning towards more of a serverless architecture. Okay, so looking through the history glass, this is one of the more familiar kind of architectures with most developers. It's a monolithic architecture, and the definition of monolithic, from what Wikipedia says, is formed of a large single block of stone. So I think that accurately defines what this particular architecture entails, in the sense that your code base is essentially a large cohesive unit of code where you have different components that talk to each other and share the same resources and memory space. So what are the pros and cons of this particular architecture? Anybody want to give it a go?
Not easily scalable.
It's not easily scalable. Anybody else? Well, that is one of the main drawbacks of this particular architecture. And the big issue around this kind of architecture, like you mentioned, is scalability, and as well, all the dependencies are tightly coupled together. So which makes it very hard for you to separate different services and actually scale them independently. Some of the good sides of this particular architecture, they say that shared memory is better than inter-process communication, which could be fairly true. But to a large extent, as your application grows, you'll find that you will encounter a couple of problems around memory and communicating with the different services, because they're all tightly coupled together, and you have a lot of side effects, and you won't actually know what is happening underneath the hood. So to put all of this into context, I'm going to tell you a story about a friend of mine. So meet my friend Dave. Dave is a developer, and Dave is a big Star Wars fan. So a couple of years ago, Dave approached me and said, like, look, I've been thinking of actually creating my own blog site. So would you assist me in actually creating the site? So then I could blog about what I love the most, which is Star Wars. And he loves blogging about Star Wars. So we went on and started creating this blog website, a very simple site that we deployed onto a monolithic architecture. And everything was going well, A few months later, Dave approached me and told me, like, hey, look, there's some people that are asking about where they can purchase Star Wars merchandise. And just by some stroke of luck, Dave's uncle, Harry, also has a shop that sells Star Wars merchandise. So what happened was Dave ended up getting the Star Wars merchandise to sell on his blog site. So immediately Dave realized that he has to build some kind of a shopping cart service on his blog site. So that kind of like scaled the whole blog site. But anyway, Dave went on and spent some weeks creating this shopping cart service that he bundled into this monolithic application. So after deploying this particular service, it started to get more traffic on the site. More people started to actually take interest in purchasing Star Wars apparel and different merchandise. And we started to actually incur some problems. where our application was now running out of memory space, and we had a whole bunch of services that we were now adding as you continuously want to enhance the user experience. So this left Dave and I in a very, very tricky situation where we started to think of how can we scale this application. And that's when we started to look into what they call a service-oriented architecture. So as you can see, this architecture has a style that is based on services, and that's pretty much the definition of a service-oriented architecture, where each particular service is a well-defined unit of functionality that is self-contained, meaning that each particular service is deployed to its own server or its own virtual machine or its own container, in a sense. And looking at this architecture, we can already see some of the advantages of it, in the sense that we can actually individually single out certain services and actually scale them. So imagine, like, from having a very simple blog post, blog site, we now had a site that had a blog functionality, and it also has some kind of shopping cart service. And you can imagine, when you have a shopping cart service, you're most likely going to have a payment service. So we now had two separate services that were actually running and were scaling beyond what we could actually cope with. So in that instance, what do? You probably look into getting more developers that can work on different services, which is great for the service-oriented architecture. And you'll find that in these kind of developer teams, where you have different teams that focus on a specific service, it is a lot easier to scale that service. It's a lot easier for that team to actually focus on delivering that particular service. It's very easy as well to remove a service or add a service, because it's not going to affect everything else in the application. So this is pretty much a service-oriented architecture where the services are decoupled from the application. They are pretty much standalone, and they work on their own, and you can have specialized developer teams that could probably write services in Java, or JavaScript, or C# or any other language that will suit that particular service. So some of the drawbacks of this architecture, like number one, is cross-cutting concerns, where you are now talking to different services, possibly written in different languages, and now you have to worry about how these different services are actually going to communicate with each other. And that is a big worry with this particular architecture. And most of the time, when you're building such a architecture, you don't quite think of all the services that you need upfront. Like, you will design something that will work at that particular point in time, but as your application grows, you start to find that you have maybe 10 or 20 more services that you're actually adding on, and that actually adds a lot of complexity within this particular architecture. Another thing is, each particular service is a standalone server or a virtual machine or some kind of container. So meaning that you will have to manage your deployments to each particular service very well, and you also have to figure out if there are no side effects when you deploy that particular service, because there are certain services that are the app depends on to actually run, and then there are certain services that the app doesn't quite depend on to continuously run. All right, so these tasks can be automated in terms of deploying to your microservices or deploying to your specific service. You can automate these tasks using container fleet management tools, like the more popular Kubernetes and Docker Swarm. We've all heard of Kubernetes and Docker Swarm? Pretty much. I'm sure most millennials are using this kind of architecture, hopefully. And it seems like this has become a very popular way of managing your infrastructure. So these two, we could actually put them in the category of what they call infrastructure as a service, or also platform as a service, where you are just simply utilizing this open source infrastructure to scale up or scale down whatever services that you actually need. So this is a basic architecture for Kubernetes, where you have your Kubernetes master and you have a couple of nodes. You obviously have to configure your Kubernetes master to know like how many nodes is it supposed to run on when it's at low capacity, and then how many nodes it should actually spin up when the traffic increases, which is quite a bit of work, you know. So looking at it, like provisioning servers is a lot of work. Like as a developer, we don't want to spend so much time provisioning servers, worrying about how much traffic is actually going to my server, you know, when should I scale up, when should I scale down. You have different services. Some services consume more resources than others, and some consume less, and actually figuring out when to run something and when not to run something becomes a very, very, you know, a time-consuming and tedious task. Here are some of the questions you'd have to ask yourself if you're into provisioning servers. And as you can see, these are just a few of the questions that, you know, we would probably ask ourselves whenever we starting a new project or a new application. Like number one is, what size servers are right for my budget? I mean, it's really hard to know upfront, right? So you'd probably start, you know, provisioning servers a little bit in the dark. You'll have a rough idea, and probably if you have a bit more experience, you know, you might have a good idea of how much you might need and how many servers you might need. And the questions go on, like what size servers are right for my performance? How can I control access to my servers, utilization of my servers, and scaling out or scaling up? And how will I deploy my code to these particular servers? There are so many varying questions, which are just a nightmare to continuously ask. So we asked ourselves all these questions whilst we were thinking of what is the best way to actually scale this this Star Wars blog slash shopping cart, to the point where Dave was just done. Dave was like, you know what, look, I'm tired of servers. I cannot hear the word server anymore. And we decided to look into something else. You know, we decided to look into something that is a lot more easier to manage and will allow us to focus on what we do best, which is writing code, right? And delivering products to people. All right, so this is kind of like a brief introduction to, you know, what we are currently using, some of us, or most of us, and some of the drawbacks with that come with provisioning your own server. So it leaves the question, what is a serverless architecture? Like I said, some say that there is no server, some say that there is a server, but the name is serverless. So it doesn't quite make sense yet, right? So like many trends in software, there is no one clear view of what serverless is. But there is one school of thought, that is, around serverless, which is highlighted in the following definitions. So AWS says, serverless computing allows you to build and run applications and services without thinking about servers. That is like a very, very basic definition from a well-known service provider, and we would hope that they would probably define it a little bit further. But this is what they had to say, that we don't want to think about servers. We don't have to think about servers, and that's basically it. Another interesting site called serverless.com also says that what serverless really means is that as a developer, you don't have to think about those servers. Like, if you really think about it, they had to add about those servers. I think the word those kind of like highlights their hatred for provisioning servers, because it's such a nightmare. You have to do DevOps, you have to do a whole bunch of things and figure out what is happening, what is failing, and what is going right. So it becomes a bit of a problem, you know, within a particular organization. But moving forward, another guy called Mike Roberts, who is the co-founder of Symphonia, explained serverless architecture as the following. He says serverless architectures are application designs that incorporate third-party backend as a service. And as well, they also incorporate ephemeral containers on a functions as a service. Now, ephemeral pretty much means something is short-lived. It doesn't last long. It's just there for a particular time and it's taken down. And these two services, or I don't know what to call them, but yeah, but pretty much services have kind of like been the building block of what we call a serverless architecture. So the whole idea around ephemeral containers is to be able to execute something when it's actually needed and pretty much put it away or destroy the whole container when you're not using it. Like, let's take a very good example. You might have a service that is called maybe 3 times in a month. It's not really very popular. And you have a running VM or a running server that is dedicated to just simply run that particular service. How much would you pay every month? You'd pay excess, right? Because it's constantly running, listening for someone or something to actually call it. In this particular instance, you will not have to really wait that long because the function is called and the container is immediately destroyed soon after that particular service has been executed. So some of the benefits, like I was saying, are significantly reduced operational costs and possibly less complexity around your server architecture, because you don't have to really worry about it because somebody else is doing all the maintenance and worrying about whether something is failing or something is actually working. And eventually this leads to you spending more time focusing on what you do best, which is writing code. Are we together? So what have we established? Like, first of all, we've established that serverless architecture encompasses 2 different but overlapping areas, which is backend as a service and functions as a service. So backend as a service is typically used by rich client applications, which includes your single page applications. I'm sure a lot of you are probably writing or deploying single page applications which allow you to utilize such kind of a service. And the whole ecosystem is cloud-based and accessible, and backend as a service provides your basic functionality that you continuously write for every single project. Take a wild guess. Authentication. Every time you have to authenticate a user and allow them to see certain things within your application. And for every project, you're constantly writing the same thing over and over again, with slight variations, of course. And another very popular thing is databases. We always have to store data somewhere, somehow, and we always have to worry about having our own database server and how it's going to talk to our application, and the list goes on. So looking at functions as a service. So functions as a service allows developers to write their own code, because if you think about a serverless platform, right, you have a third party providing everything for you. Well, pretty much everything. But a lot of the times we want to write our own custom code, right? We want to write our own functions, our own PDF generators somewhere, and we really want to have our own custom code. So functions as a service allows us to write our own custom functions that we can deploy onto these platforms. But the most important thing is we don't have to worry about the infrastructure. We just simply deploy to this particular platform, and these platforms are very smart and they probably use the latest tech. And obviously, like some of the big guys like Amazon, Google, and Microsoft probably use a containerized system where a function is called at a particular time, and as soon as that particular function executes, the whole container is just destroyed and we don't have to waste money and resources continuously listening for someone else to actually call that particular function. So what I have here is a typical serverless kind of architecture where you have your front-end logic, which is obviously some kind of single-page app or some kind of application, and then you have some database structure and you have some security measure, which is probably authentication, and you have some back-end logic, which is a whole bunch of containers listening or waiting to, or listening for event triggers to execute that particular service. So we're going to have a look at the top 5 industry leaders in the serverless platform. And at the top of the list, you have AWS Lambda, which has probably 80% of the functions as a service platform. And these are kind of like currently the industry leaders, I would say, in providing this particular service. This was created, AWS Lambda was created in 2005, if I remember well, and each particular function is triggered by an event. So a certain event happens and that function is triggered. And that function is probably triggered in a very pristine kind of environment where it executes, and as soon as it executes, it no longer is required for that particular service. So we kind of like just to destroy that whole container afterwards. And after that, we have Microsoft Azure, which was Microsoft's response to AWS Lambda, which is pretty much the exact same thing as AWS Lambda. It's only that they have a different way of handling what happens to a container if that function hasn't been called for a while, and there's a bit of a delay, I guess, in the way that they call functions. I haven't quite researched much about Microsoft Azure, but from what I read, that it's pretty much exactly the same as AWS Lambda. Trailing at number 3 is Google App Engine. Now, this is a very interesting platform. If anybody has ever played on the Google Cloud platform. Google App Engine actually is a great solution for developers to create fully fledged applications without having to worry about performance and scaling. So pretty much they will take care of your hosting, they will take care of your scaling, and manage also a whole bunch of other things that they have included in their package. And Google App Engine as well also offers automatic scaling in case that your application starts to get more traffic. They actually know how to automatically scale your infrastructure. Okay, so after that we have Google Cloud Functions. So these are like part of the same company, but 2 separate services that are actually being provided. And Google Cloud Functions is very similar to AWS Lambda. It is pretty much a container system where functions are run when some event is triggered, and that function executes and the container is no longer available. As well, it also scales on its own, and it's also designed for small functions that go under heavy workload. And it's mainly like a Node.js environment that is fully managed by Google, and it handles all the security issues and performance issues around that. So lastly, we have IBM OpenWhisk, which is pretty much as well a functions as a service, and pretty much exactly the same as AWS Lambda and the others. The only difference is that this particular service, you can actually host it on your own local servers if you're really into servers that much. So it just really depends. So these are some of the industry leaders, and we all know these well-known names. They pour in a lot of money and a lot of resources to get all these things going, and they are kind of like solving the problems that developers are facing every single day. And one of the problems that we face is servers, because sometimes there really is no point of always constantly provisioning servers and constantly having to go through the whole DevOps and deployment pipeline, because we are serving in a world where clients are key, right? And clients want their stuff like yesterday. So that is pretty much the top five in this game. So we want to draw some attention to the Google App Engine specifically, actually more of Google as a provider and some of the advancements they have made in this particular area of serverless architecture. So we're going to kind of like wind back a little bit and look at what this app engine really is and what it actually offers. So there has been a lot of things that have happened between the time the app engine was launched and what it is now. So Google App Engine was essentially launched in 2008 in April. It was more like of a for a specific group of developers. Apparently they launched this for like 20,000 developers, just to kind of like test out the whole platform and see how everything works. And it was then officially launched in 2011. And since then, almost every other month and every other year, they have been adding a whole lot of stuff. Support for different languages, support for different platforms. I will probably mention a couple of the key things that I think were really important that allowed us to get to a place where we could utilize a serverless architecture. So one of the key things that Google did was on June 2014, they launched Kubernetes as an open source container manager. And this also supported Docker images. And Docker is a very, very popular container system that allows us to do certain things and run certain programs and different applications without necessarily having to worry too much about infrastructure issues. Moving on to that, the same year, a little bit later in October, they acquired what we call Firebase. Now, we all know Firebase, right? It's a very popular Google platform, and this was acquired in 2014. Now, the interesting thing is that Firebase, I think Firebase was launched, it must have been in 2010 or 2009 by two guys, and it was first called Evolve. And this then evolved to Firebase, because what they realized is that a lot of people were actually using their platform for things that they quite hadn't created their platform for. Mainly, they were trying to allow people to have like real-time chatting system, like some kind of a real-time chatting system, and then developers ended up using it to pass data to different applications, and that's how they then created something called Firebase. But we'll dig a lot more into that a bit later. So, fast forwarding a little bit to 2015, I think this is also a very important element. The Google App Engine launched something that they called the preemptible VMs. Now, we saw earlier in the service-oriented architecture that each particular service will have its own particular VM or a particular container. So preemptible VMs are pretty much the same as ordinary virtual machines, but the only difference is that they can be shut down when they're not being used, and they can be spun back up when they need to be used. And what does this help with? It helps us not to overspend or have a massive budget for like servers and things along those lines. So these were some of the key things that kind of like gave birth to what we have now as a serverless system on the Google Cloud platform. All right, so like I mentioned earlier, one last thing that I actually left out is that Google Cloud Functions was introduced in 2017, and this also became a package as part of the Google Cloud platform system. So you can imagine a combination of the app engine and Google Cloud Functions. It becomes a very, very powerful platform. And all these technologies were then incorporated into Firebase, and which made Firebase what it is today. A very robust kind of system where we don't have to worry about servers, and they offer us pretty much everything that we need to get up and running with development quickly. Okay, so we're going to have a look at the Firebase architecture, and this is pretty much what a Firebase architecture is. It's very simple as compared to some of the diagrams that we saw earlier. You have a bunch of devices or interfaces, and then you have Firebase doing its magic, and you have some managed VMs and a containerized system. Now, this is a very high-level diagram. It doesn't show much detail on how everything works underneath the hood, which is very difficult to find because you'd have to kind of like dig through a lot of different things to really understand how everything pieces together. But I think from this kind of like history, we now have a slight understanding of how everything kind of like was pieced together to form Firebase, which is actually what I'm currently using for most of my projects right now. So Firebase offers us similar services. Like I said, that we have our backend as a service, which allows us to authenticate and allows us to add things to the database without provisioning servers. And it also gives us good storage facility that we don't also have to provision as well. And the good thing is you only pay for what you're actually using, so which is a big plus on the pockets of most either startups or organizations running a lot of servers. So this is pretty much like what a backend as a service diagram would look like. We have no idea what they're doing in the backend there, and different platforms will probably provide different services. Like I said, authentication, databases, and storage are just 3 of the wide range of services that they actually provide. So all you just simply worry about is writing your code on the front end, and everything else is handled by Firebase. I've already explained exactly what a backend as a service is, and this is a typical example of a functions as a service. What we have here is some kind of database that is that a message is being written to, and we have an event trigger that will trigger a function as soon as a message is written, and it will sanitize that function and return it back to the database. So think about it this way. You can actually have a image uploading functionality where you can upload any size image, and you can have a function trigger that will listen and get that particular image, resize it, and then load it back. So you won't have to worry about resizing things up front. It can all be done in the back end, and a user will never have to know that this is actually what is going on. Cool. So I think I prepared a little demo. Like I said, it was a bit of an impromptu kind of talk. Oh, sorry. This is typically what a functions as a service would look like. You'd have your HTTP requests, so you can actually do a request to a function that will be triggered from any particular application, or you can call your function from inside the application and it will still execute. Cool. So just to, all right, like I was explaining earlier on, this would be your configuration, and then you would initialize each of the particular services that you actually want to use. Like I was saying, the database and the storage and the functions, depending on what you actually want to use within your application. Now I'm trying to exit from this. Okay, so what I want to show you next is how simple it is to have your authentication within your application. Presentation mode. Cool. So this is pretty much it. Like, you would literally have a auth listener that just simply listens to see if someone is authenticated or not. And this will automatically send you the user's unique ID that will show you that a person is authenticated or not. Now, if you really think about this and how much code we would write initially to just get authentication up and running in any application, it'll probably take you a couple of days to just get that right. And with this here, in a matter of like 5 to 10 minutes, you could literally be done with authentication, which is pretty much the power of a serverless architecture. This particular architecture, like I was saying, offers a whole lot more than what I'm actually showing you. It's only that we cannot quite exhaust the entire list of things, but pretty much, you know, that is pretty much how simple it is to get things up and running. So, in conclusion, serverless architecture. Oh, okay. So we now know that there are servers somewhere. It's not like there are no servers at all. There are servers, but we just don't manage these servers. It's someone else's job. Because where you would take, like, 2 weeks to provision servers and create your deployment pipeline and make sure that you have the right operating system and the right dependencies, you are just literally ignoring all that and just simply deploying your application for users to start using. So we're not worrying about servers. We now know that there is a backend as a service, which is pretty much all the services that I was showing you, and there's a functions as a service where you can write your own functions, deploy them, and actually have event listeners that will trigger these different functions for different services. And that's pretty much it. Cool.